Okay, for this last one that I'm going to go over, it's a very special case, so that's why I wanted to pay close attention to it. But let's again review that formula, review what we're trying to accomplish. So in this case, we've got two starting points, K, or we've got 2 points, K and L, and I want to split it in a 1-to-1 ratio, which if it's a 1-to-1 ratio, that means we're split right down the middle. That should mean something to you, right down the middle. So there's one here, the total amount of pieces between the two is 2. So if my starting point is K, that's going to be my x1, y1, and my L is my x2, y2. Substituting into the formula, we have x1, which is 1, plus A and B are both 1, so 1 over 1 plus 1, times -5 minus 1, comma, y1, -3, plus 1 over 1 plus 1, times y2 minus y1. And notice that I have a -3, so I put that -3 in parentheses because I know subtracting a negative number will turn into a positive. So 1 plus 1 over 2, -5 minus 1 is -6. Okay, -3, 1 over 2. I don't know why I put parentheses. Let me go back. -3 plus 1 over 2. 9 plus 3 would become 12. That becomes 1 plus a -3, comma, -3 plus 6. This will be -2, 3. So my point that partitions is -2, 3. But the reason that I wanted to pay close attention to this example is because a 1-to-1 ratio where something is exactly in the middle has another name. It's known as the, drum roll, bad drumming, sorry, is the midpoint. So the midpoint. And you may have seen the midpoint formula before, which we had x1 plus x2 over 2 and y1 plus y2 over 2. Okay, when I add those two values together, I get my x value is 1 plus -5 over 2 and 9 plus -3 over 2. Well, 1 plus -5 is -4 over 2, and 9 plus -3 is 6 over 2, which ultimately reduces to -2, 3. So the midpoint formula comes from partitioning a directed line segment. Both of these formulas are formulas that you've seen before now, or especially that midpoint formula, but will give you the same result because we're trying to find the middle point.